and we certainly never complete one layer without doing the next layer at the same time. We try not to order the layers that way. Thin little spikes all the way through. And then once we have the system working in a thin little slice, then we start to widen it. Progressively widening it. Every iteration adding a few more of these spikes. Every iteration growing the system all the way from the GUI to the database. That is progressive widening. We also practice progressive deepening. Progressive deepening is the notion that we do not create that slice, that thin little slice, in all layers at the same time. We focus it and get something working in one layer, and then we start to pull it out into many layers. I sat down with a group of guys, about a year and a half ago. And they had to implement a feature, a tiny little feature. It was a login page. And I sat with one of them, and he started to write code, and he was writing the GUI. And I said, fine, okay. So I'm sitting there with him, pair programming with him, writing the GUI. And he got to the point where he had to call the middleware. And he stopped. And I said, well, why are you stopping? He said, well, the middleware's not written yet. I said, well, don't worry about that. Just call the database function right here. See if you can get this thing to work. You don't have to worry about the layer. Just see if you can get it to work right here. Oh, no. We can't do that. That would violate our process. Yeah. Fine. But at least you can see the thing working. And then once you had it working, you could pull it apart into the layer. It took me a little while to twist his arm, but after another half an hour, we had the whole login page working all up in the GUI. Now, of course, that's terrible design, but we had it working. And then we were able to start pulling it out. Okay, now we understand how the GUI is going to talk to this middleware. So now we can define the interface and put in the SOAP connection. And now it's down in the middleware. The middleware was calling the database directly, but then we can pull that apart too. Progressive deepening. Start with something that works, and then pull it through the architecture. There's an old saying. I don't remember who coined it. First make it work, then make it right, then make it fast. Well, Ken certainly did say it. I think the reference goes back before that, though. And I don't remember the final originator. Might have been Ken, I just don't remember. This one should be obvious. How many of you have been significantly impeded by bad code? How many of you have been slowed down by bad code? Now look around, that's virtually 100% of you. Why did you write it? Laugh if you like. But that's a serious question. Why did we write this bad code? We have all experienced being slowed down by bad code. We've all experienced the horror of bringing a module up on our screen and seeing the tangled mass of ick. Why did we write that mess? Now, we can say to ourselves, well, I didn't write that code. Somebody else wrote it. Yeah, but we wrote the code that they're looking at and they're horrified by. Why did we write it? Well, we have all kinds of excuses for this. We say to ourselves, we didn't have time not to write it well. We didn't have time to write it well. We didn't have time. Now, excuse me, I'm confused. Wait. You are going to be significantly slowed down by this code, but you did not have time to avoid being significantly slowed down. Yes, you're agreeing with me. Good. I submit to you that that's nonsense. Nonsense. Right? Because the slowdown is not something that occurs months from now. The slowdown is immediate. How many of you have stared at the code you wrote 2 hours ago and thought, what the hell does this do? Yes, significantly impeded by your own bad code 2 hours ago. Bad code is not something that slows someone else down months from now. It slows us down immediately. We must not write bad code. Period. A fundamental issue of professional behavior. We must not write bad code. The only way to go fast is to go well. To write the best code we can all the time. Oh, but management will never allow this. Who's going out of management that will not allow them to write good code. That's ridiculous. Let me tell you a story. I had a couple of apprentices working for me a few years ago. They were writing a calendar application. And we went through a little requirements analysis. We put some stories together. They were going to do it in a few iterations. They put together an estimate. I judged the schedule, said, okay, fine, go ahead. They came back to me much too soon with a calendar application that was working. And they were very happy about this. Oh, we've done it in half the time. Aren't we great? And I said, well, okay, this is good. Can I see the code, please? And they showed me the code. The code was a mess. And I said, well, look, this is a mess. You're going to have to clean it up. And they said, yeah, but it's going to be really expensive to clean it up. Aren't you happy that we got it done in time? I said, no. I'm not happy that you got it done early, because maybe you saved me a few $1,000s, or maybe you think you saved me a few $1,000s of your petty hourly rate, but you don't quite understand that I am going to be betting hundreds of thousands of dollars on the correct operation of this software. I need it to work. I need it to be high quality. I need it to be good code. So don't give me any of this, ooh, we got it done fast nonsense. I want it right, because I'm putting my company at stake on the code you are writing. And I sent them back and made them write it correctly. What is our product? We are software developers. What is our product? Our product is code. It's not the behavior of the system, although we certainly create that behavior of the system for our customers. Our product is code. That is the material that we work with. And when the code is a mess, so is the product. It doesn't matter whether the product is functioning correctly. If the code is a mess, the product is a mess. Nothing has a more long-term degradation effect than bad code. We complain all the time about bad schedules, bad managers, bad requirements. Oh, the system is a mess because the requirements changed all the time, or the system is a mess because management has this unrealistic expectation. Silliness. Bad schedules can be fixed. Bad requirements can be redefined. Bad team dynamics can be solved, usually by firing somebody. But bad code stays. It stays forever, dragging the team down and often the company with it. It becomes this messy weight that slows down the team forever. How many of you have been on a project where you started with very little code, greenfield project, and you were working miracles? You were getting stuff done every week, and you were going fast, and life was good. And then a year later, it took forever to do anything. Every bug you fixed introduced 2 more bugs. Every new feature had horrible complications. This productivity decline is because of bad code. Don't write it. Because the only way to go fast is to go well. This little green band here sits on my wrist and it tells me, don't make that mess. Don't go fast, so fast that you make a mess. Slow down a minute. Write that code well so that you don't impede yourself later. The only way to go fast is to go well. Write clean code. What is clean code? What do I mean by clean code? What does it mean for code to be clean? How big should a function be? What's that? 8? Did you say 8? Oh, 10. 10 lines of code. That's a nice number. Anybody else got a definition? It takes you 5 minutes to understand it. This is an excellent definition of clean code. It has nothing to do with the size of the function. It has to do with the ease of understanding. Ward Cunningham once answered this question. He said, the code reads in such a way that every line of code is what you expect it to be. As you're reading down the program, there are no surprises. Every bit of code is what you expect. Think about that. Think about writing code in a way that as you read it, it's obvious. How big should a function be? I like my functions to be fairly small. Who has heard the old standard that it should be a screenful? This was true when our screens were VT100s. Right?